Niels Bohr proposed out or say suggested some doubts in Rutherford's model, and later on he considered Rutherford's model as standard model only with certain changes. Say for example, this is a nucleus. Rutherford is saying electrons are revolving around that nucleus in circular orbit. Instead of that, now correction is that it is revolving in spherical way. So three-dimensional view is there. Niels Bohr put forward a derivation. By that derivation, he was able to prove that when electrons, when they are revolving in particular prescribed path, that is called as, according to him, he called that as orbital or orbit. So if that electron is following that prescribed path, then it will not fall in the nucleus. It will remain unchanged. So it will follow either spherical path but not change out to the spiral path and fall in the nucleus. Step by step, electron can be promoted to upper orbital by absorbing energy and lower orbital by releasing energy. Like that, concepts were introduced by Niels Bohr, but right now what I am speaking, I must explain it in detail. So let us start now. Instead of that Bohr's derivation, because I am going to take that derivation but not in this part. So in some other lecture, I will give that entire derivation, because right now we are interested in electronic configuration and atomic structure. So just consider that outcome of that derivation we are discussing now. So first part, that is how electrons are arranged in the atom. See, initially we were having doubt whether atom is there or not. Then subatomic particles were produced. Now what is atomic structure? After that we say that where and how electrons are arranged. So for that purpose, Niels Bohr put forward certain laws. No doubt, it is not that Niels Bohr thought therefore he placed. No, with mathematical expressions he said these are the things they are going to happen. So out of that, first important thing, that what is the capacity of atom, orbital. So we have to discuss now capacity of orbital. This is nucleus. This is first orbit, second orbit, third orbit, and so on. Niels Bohr says that capacity of orbit is equal to 2n square, provided n is orbit number. So suppose I am talking about, this is the nucleus, this is first orbit, this is second, third, like that orbits are there. Then first orbit, second orbit, third orbit. How many electrons can be there in orbit? For that purpose he says that number of electrons, the maximum number of electrons they can be there, that is equal to 2 into n square. So n stands for number of orbit. So in first orbit, 2 into 1 square. So you are aware that 2 into 1 square is 1. So answer is 2. Second orbit means n equal to 2. Then 2 into 2 square, that will be equal to 2 into 4, that is 8. Now this way you can calculate n equal to 3. Then 2 into 3 square, that will be 2 into 9, so 18, and so on. So this is the condition. But how many electrons are there in atom? That topic now we have to discuss. So here we are now discussing how many electrons, protons, neutrons they are there in atom. Any element, we can give some symbols, say for example X. Now you are aware that these symbols, they are given in Latin language. Therefore, name of element should be there in Latin. Whatever the Latin name is there, accordingly symbols are given. But I am just describing here how element is written. So this is some symbol X of that element. Here we are writing A and here Z. A stands for mass number. Z stands for atomic number. Now, what is A? A stands for mass number. So, A, that is equal to number of protons plus number of neutrons. Why? Because properties of an subatomic particles. You are aware that proton is having charge +1. Keep in mind, actual charge is different. But for general consideration, we are taking this charge as +1. Who discovered proton? Try to recollect. In wrong experiment by Goldstein. So charge is +1. Then mass, for general purpose, we are considering 1 AMU. That is 1 atomic mass unit. For detail, it is considered as 1.0078 AMU. So these are the important thing. Location in the nucleus. Who discovered Goldstein? Second particle, neutron. Neutron was proposed by Rutherford only. But because we are aware that in the tiny nucleus, all protons are staying together, which is just impossible. To answer that, Rutherford says that there must be some neutral particle that is coming in between. That's why he suggested neutron. But it was proved in much later date. In 1932, neutron was proved by Chadwick. So here, neutron charge is 0. It is not having any charge. Mass for general purpose 1 AMU. But for detail purpose, it is 1.0086 AMU. Whereas location in the nucleus. The last particle here, that is electron. We are aware this is actually first subatomic particle discovered by Sir J.J. Thomson. It is having charge exactly equal to proton but opposite. So proton is having +1 charge, electron is having -1 charge. Mass of electron is not constant. According to speed, mass of electron changes. But for general practice, we are considering it is 0.000555 AMU. Or rather I should say that is equal to 1 by 1850 AMU. That means 1850 electron will come together, then mass will be equal to 1. So electrons are as compared to proton and neutron, electrons are having negligible mass. And therefore, mass number is denoted by only number of protons plus number of neutrons. Whereas atomic number Z is only number of protons. But you are aware that total number of proton equal to total number of electron in any atom. And therefore, we can consider whatever number of protons, that is number of electron. And this way, Z, that will give you number of proton plus number of electron. Are you able to follow? Or let us go by some example. So let us check out example sodium. No doubt I am talking sodium and writing Na because Latin name of this element is natrium and therefore symbol is Na. Its atomic number is 11 and mass number is 23. Now mass number is 23, atomic number is 11. We have to find out A. A is number of protons plus number of neutrons. Z is what? Number of proton. So the Z is 11. That is equal to number of proton and that is also equal to number of electron. So in atom, number of electron is same as number of proton. Therefore, in case of sodium, 11 protons are there and 11 electrons are there. Now, A is 23. Number of proton we got 11 plus number of neutron. So number of neutron, that is equal to 23 minus 11, that is equal to 12. So simply we can say that A minus Z will give me number of neutron. So 23 minus 11, I am getting number of neutron. So this way we can calculate number of protons, neutrons and electrons in any atom. So now you are aware of these all atoms. They are having characteristic, that is atomic number. And accordingly atoms are now arranged. Now you are aware about the fundamental particles property. Some of the particles we discussed. Why I am saying some of the particles? Because we are at beginning right now. There are so many subatomic particles. They are not always present. At certain part only they can show their presence. Say for example you are aware of electron. Now like that similar particle but opposite in charge is present, that is called as positron. Then there are mesons and so many. So we are discussing right now only fewer particles in the atom. So we discuss proton, neutron, electron, basic part. So this is the way. Now we are switching over to electronic configuration. Now we are going to discuss how electrons are arranged in a shell. This is some primitive level electronic configuration we are going to discuss. Why I am saying primitive level? Because after getting concepts clear, we are going to discuss some higher level electronic configuration also. So now you are aware how many electrons are there in atom. That is, you are aware that is equal to their atomic number. Now you are aware that there are orbits. Different shells are there. Electrons are assigned in their shells. You are also aware that capacity of shell is 2n square. Now I am trying to prepare a table over here. So here I will write name of electron, name of atom. So suppose I am writing here sodium, atomic number 11, mass number 23. Now here number of electrons in atom. So you are aware that atomic number, that is equal to number of electrons in any atom. Actually it is number of protons, but in any neutral atom number of proton is equal to number of electrons. Therefore I am writing here number of electron as 11. But this is not only sufficient. Capacity. So here I am writing n equal to 1. That is the first shell. Capacity or number of electrons, that is equal to 2n square. So 2n square will be equal to 2. This shell is also denoted as letter K. Now n equal to 2. So 2n square will be equal to 2 into 2 square. So 2 4s are 8. So here capacity is 8. This shell is denoted by letter L. N equal to 3. So 2n square, that will be 3 3s are 9. 9 2s are 18. So 18. This is denoted by letter M. Next shell n equal to 4. 2n square will be 4 4s are 16 into 2 32. Shell is denoted by letter N. N equal to 5. Obviously 5 5s are 25, 2s are 50. Capacity is 50. This is denoted by letter O. So in table we are writing out number of electrons here. Every time you have to keep in mind here 2 electrons, 8 electrons, 18 electrons, 32 and 50. Now let us first go for sodium, atomic number 11. So as atomic number 11, number of electrons we have to assign there also 11. Now first shell, now what Bohr says, the first rule. The first rule is that we have to fill lower shells first and then upper shell. So here I will go for n equal to 1. First shell, I will fill 2 electrons here. Whereas total available electrons are 11. Out of that 2 are accommodated here. Now remainder 9. So here I have to keep 8 electrons because capacity of this shell is 8. So I have placed 8. 8 plus 2, 10. Here 11 electrons are there, therefore remainder is 1. And then last electron I can keep here. No doubt capacity is of 18. But less than 18 are allowed. More than 18 not allowed. So I have placed 1 electron. So this way we can write electronic configuration of sodium in this way, that is 2, 8, 1. 2, 8, 1. So this way we are writing out electronic configuration of sodium. I will write here also 2, 8, 1. This way we can write configuration of sodium. Now next element, okay, let me check whether you are able to follow or not. So next element I will give here, that is phosphorus, atomic number 15, mass number 31. So atomic number is 15 over here. So you have to go back phosphorus now. So number of, pause this video and try to carry out electronic configuration yourself first. And then start this video and check out. So number of electron 15, first shell 2, as it is maximum. 8, second shell. 8 plus 2, 10, remainder 5. Whereas last shell is having capacity 18. So I can keep 5 electrons as it is. So this way, electronic configuration of phosphorus, I can write 2, 8, 5. This way. So this is the case. We can check out electronic configuration with this rule. This is given by Niels Bohr, and we are making table, trying to make table more advanced possible. Let us check now electronic configuration of calcium. But for that purpose, we have to check another rule also. Let me clarify that another rule. So first I will write here electronic configuration of calcium 20, mass number 40. So as this number is 20, number of electrons available is 20. I have to accommodate now 20 electrons in all this shell. Now, as earlier, this is 2, 8, so 2 plus 8, 10, remainder 10. Here capacity is 18, so I should write 10 here. But here Bohr placed another rule that if last shell is having more than 8 electrons not permitted, we can keep at the most 8 electrons in this last shell. And therefore, I have to remove this 10 and I have to place here 8 only. So, irrespective of capacity, I have to give only 8 electrons in last shell. So, I have placed here 8. Remainder is now 2 and that is placed in next shell. So, that's why configuration of calcium, I am writing 2, 8, 8, 2 and not 2, 8 and 10. Because if I am considering 2, 8 and 10, then last shell is having more than 8 electrons, not permitted. Getting idea? Now you try yourself one more element here, that is potassium, atomic number 19, mass number 39. You try. Pause this video and then observe this video. Now it is same to same like calcium only, number of electrons 19, first shell 2 electron, second shell 8, 2 plus 8, 10, remainder 9. So supposed to be, I have to write here 9, but we are aware of this rule, last shell should not have more than 8 electrons and therefore I am removing this. Here I am writing 8 and last shell is having 1 electron. So configuration is 2, 8, 8, 1. Getting idea? So this is something, the expected electronic configuration according to this table. Now condition is that here some questions are always there in my mind, that why 8 electrons I have to place here, because ultimately it is not last shell now. Initially when 10 electrons are there, it is last shell, But now 2 electrons are here. So can I shift 7 electron and 3 electron, 6 electron and 4 electron, 5 electrons and 5 electrons, like that also? And therefore we have problem. To solve this type of thing, these electronic configurations are used till only here. Suppose scandium is next element, atomic number 21, how we are going to assign? And like that various questions are there. And this can be solved by next configuration given by Niels Bohr, that is called as Aufbau principle. With help of Aufbau principle, we can give certainly answers of these all questions. So let us check now Aufbau principle.